Hello, welcome to the video. In this lesson, we're going to be looking at section 7.5, where we're going to be solving rational equations. So, central question on this slide asks, how can you solve rational equations? Well, we are going to be solving rational equations by using cross products or cross multiplication. One of the things that we have to do in order to be able to solve rational equations using cross products is we have to make sure that we have exactly one fraction on the left-hand side and exactly one fraction on the right-hand side. If it's not that case, we kind of have to do some manipulation of each side of the equal sign in order to make that true. So looking at um, this first example, we have to ask the question is how many fractions are on each side? Well, there's just one on each side, so that's great. What we can do is we can now solve it using the cross product. So I multiply over here and I multiply over here. So looking at it first, I'm going to say that this is going to be 9 times by the quantity of x plus 1, and that's going to be equal to 3 times by the quantity of 4x plus 5. I do that initially because sometimes, not all the time, there may be something that you might be able to cancel right away, and you won't have to do as much multiplying um, as originally anticipated. But looking at this one, there's nothing else that can be canceled out right at this. Well, I guess you could do this. So like say like I have the 9 and I have the 3. This is they're both divisible by 3, so this turns into 1, this turns into 3. So yeah, I guess there is some cancellations that could possibly occur. So what I have on the right-hand side is just 4x plus 5, and on the left-hand side I have 3x plus 3. So then from here, we just, so I've solved for the variable, so I'm going to subtract 3x to both sides. I'm going to subtract 5 from both sides. So now I have this cancels, so I'm left with negative 2 is equal to x. So the last thing you have to kind of check for this particular problem is to make sure that negative 2 doesn't make your original equation undefined. So if I put negative 2 here, negative 2 plus 1 is negative 1. It's not 0. We're good. I go over here, negative 2 times 4 is negative 8, negative 8 plus 5, negative 3, it's not 0, we're good. So this checks out. So that's when we have to check your solutions, because if for some reason you have an answer that makes your original expression undefined, you can't use that solution. Okay, so please make sure you check them. So each one of these has one fraction on the left and the right hand side. I'm just going to pick one, and let's just look at number 3. So looking at this particular one, multiplying using the cross products. When I do that, it turns into x times it by 2x plus 5, and that's going to be equal to 1 times by 11x plus 8. Nothing appears that I can easily cancel out. So this is going to turn into 2x squared plus 5x is going to be equal to 11x plus 8. So what we have here with the x squared is we have a quadratic. Since we have a quadratic, I have to set my equation equal to 0. So this is, I'm just going to subtract 11x, subtract 8. So now this turns into 2x squared minus 6x minus 8 is set equal to 0. So with this one, I can divide everything by 2 because 2, 6, 8, all divisible by 2. Um, it becomes x squared minus 3x minus 4 is equal to 0. I go parentheses, parentheses. I get x here, x here. Different signs, large numbers attached to the minus. Are there two values? Give me a product of 4, but the difference is 3. It would be 4 and 1. Zero product property tells me that x is going to equal to -1 and x is going to be equal to +4. So just double checking real quick. -1 up on the top. That's good. That one will be good. For 4, good for that one, good for that one. All right, we're good. So both of these answers would in fact be solutions to this problem. Where we find that we have a little bit of a challenge is when you have more than one fraction on one side of an equal sign. So if you look here, I have two fractions on the left-hand side, and I just have one fraction on the right-hand side. So what we have to do with an example like A is we have to make this uh, set of fractions into one fraction. So what we have to do is we're going to have to use the method that we did in the previous section about adding and subtracting rational expressions. I need to find the LCD between the two. All right, so since 4 and x can't be factored, I'm going to say my LCD in this particular instance is 4x because I just multiplied them together. So now I have 4x here plus 4x here. X is good, but I multiplied this 4, so that means 5 times 4 is 20 up on top. 4 is good on there. X, so that means it's going to be 7x. So looking at the left-hand side, when I combine like terms, I'm just going to go 7x plus 20. I'm just rewriting in standard form, all divided by 4x. And this is going to be equal to -9 over x. So now I have one fraction on the left-hand side, one fraction on the right-hand side. I can go about doing my cross product. So multiplying the cross products, I get -9 times it by 4x is going to be equal to x times it by 7x plus 20. So now from here, as I look at this, nothing I can easily cancel out. So this turns into negative 36x. This is going to turn into 7x squared plus 20x. And what do we get here? I'm just going to add 36x to both sides. So now I have 0 is equal to 7x squared plus, what, 56x? So here, when I factor this out, I can go 0 is equal to, what, 7x, and then this is going to be x plus 8. Zero product property tells me that this here, x will be equal to 0, and here, x is going to be equal to -8. So looking at these two solutions, if I were to put 0 in here or in here, it would make the equation undefined. So this one here doesn't work out, but let me look at -8. We're good. So the only answer that works in this particular situation is x is equal to -8. If I looked at B, I have essentially two fractions. This is like 1 over 1, so that's one fraction, and then the minus 8 over x minus 5, that's the other fraction. 3 over x is just the one fraction on the right hand side, so I got to make these two fractions into one fraction. So try to find the LCD here. 1 times x minus 5, well, that's just going to be x minus 5. So on the left hand side, I get x minus 5 over x minus 5, because that's 1, minus, I didn't change anything here, so it's just going to be 8 over x minus 5. So I get my like terms, x minus, so this is going to be from negative 5 minus 8, so that's going to be what, minus 13, that's going to be over x minus 5, and this is going to be equal to 3 over x. So, with that being said, now we're going to do the cross products. When I do that, I get x times it by x minus 13. This is going to be equal to 3 times by x minus 5. Nothing here that I can easily cancel out. So now this is going to turn into x squared minus 13x. And this is going to be equal to 3x minus 15. So because it's x squared, it's quadratic, set it equal to 0. So this turns into x squared minus 16x plus 15 is set equal to 0. When I factor this out, x here and x here, same sign minus. Two values give me a product of 15, but their sum is 16, would be 15 and 1. So x will equal 15 and x will equal 1. Checking our solutions here, both 1 and 15 would make them defined. So this is a situation where both answers would work. All right, so looking at these ones here, again, I'm gonna do number 6. But if you have questions on 4 or 5, please leave a comment. I'm more than happy to work those out. But I bet you looking at 4 is probably the more challenging of the 3. So looking at this, I want to find my LCD between x squared minus 1 and 1. So LCD is going to be x squared minus 1. So this is going to be 12 over x squared minus 1 plus 3 over x squared minus 1, all divided by x squared minus 1. When I distribute this, this is going to be 3x squared minus 3, so I just kind of cross that out. So when it's all said and done here, it's going to be 3x squared, 12 plus a negative 3, it's going to be what, plus 9, and that's going to be all divided by x squared minus 1, so that's going to be equal to 4x plus 1 over x plus 1. So now I got one fraction on the left, one fraction on the right. So now I can do the cross products. So what I'm going to do, so looking at this one here, this is going to be 4x plus 1 times it by the quantity of x squared minus 1. And that is going to be equal to this product here, which is going to be x plus 1 times by the quantity of 3x squared plus 9. So what I am going to attempt to do first is there appears to be some of these parentheses that can be factored out, and maybe through this doing some factoring, there may be stuff that I can cancel. So I can actually factor x squared minus 1 because it's a sum and difference pattern. And I can also factor this one here. So let's see if that will help us at all. So this is going to turn into 4x plus 1, stays the same. This is going to be x plus 1 times by the quantity of x minus 1. This could be equal to x plus 1. And then this is going to be 3 times it by x squared plus 9. So x plus 1's get canceled. Um, so essentially, this didn't help me at all in a cancelization sense. So what we're going to do is I'm just going to go back and Oh, actually, this will be 3. Sorry. Still didn't help me in a cancellation sense, so I'm going to redistribute it. So I'm going to factor these two out. When I factor these two out, I get 4x squared minus 4x plus x minus 1 is equal to 3x squared plus 9. So it's quadratic. Set it equal to 0, so I'm going to subtract 3x squared. I'm going to subtract 9. So when I get there, I get x squared minus 3x minus 10 is equal to 0. So let's see. So I get what, x squared, no, sorry. Factor this out. See if I can factor it out. Hopefully I can. X and x, different signs, larger numbers attached to the minus. It's going to be what, 5 and 2. So x is going to be equal to negative 2. X is going to be equal to positive 5. Looking back here with 2 and negative 2 and positive 5, both of those would be defined. So um, they're both going to be solutions in this particular instance. And you can check those, and you can even check those if you'd like to see if they're going to be true statements in both of them, and they will be. So again, still trying to solve for using the cross products, but again, we got to get one fraction on the left, one fraction on the right. So looking at this right-hand side of the equal sign, so I'll try to find the LCD here. If I factor this one out, this is going to be x plus 3, x minus 3 because it's a sum and difference pattern, and then this is just going to be x plus 3. So my LCD is going to be x plus 3 times by the quantity of x minus 3. Looking here, I got 8x squared all divided by the LCD minus x plus 3 is right there. X minus 3 is not, so I gotta take 4x and times it by x minus 3 on the top. So now I got 8x squared all divided by the LCD minus 4x squared minus 12x all divided by the LCD. So when I combined the like terms, so this is going to be 6 over x minus 3 is going to be equal to, looks like 4x squared plus 12x all divided by x plus 3 times by the quantity of x minus 3. Okay, so if I do the cross products here, this turns into 6 times by x plus 3 times by the quantity of x minus 3. This is going to be equal to x minus 3 times by the quantity of 4x squared plus 12x. All right, I already notice that this x minus 3 and x minus 3 are the same, so they cancel out to be 1. I can factor this out. Let's see if that'll help us at all. So now I got 6 times by the quantity of x plus 3 is equal to, this is going to be 4x times by the quantity of x plus 3. So this is the same, so this gets canceled and this gets canceled. So now all I have is 6 is equal to 4x. Divide everything by 4. X is going to be equal to 3 halves. So 3 halves, looking at each individual denominator, it's not going to make the denominator undefined. Not going to make it 0. It is in fact our solution. Last thing we're going to look at is it says consider the function f of x is equal to 2 over x plus 3. So if you were to essentially graph this, if you recall when we were graphing rational expressions, so like here, our vertical asymptote would be at -3, so 1, 2, -3, so it looks something like this. Horizontal asymptote would be at 0, so this is like our new 0, 0. Since 2 is positive, our graph is going to look something kind of like this, if you recall. They wanted us to determine whether the inverse is a function. So if, again, if we use the horizontal line test, I'm going to get a different color. So here's my horizontal line. And you can tell that it doesn't cross more than one spot. So in this particular instance, the inverse is a function. Then the next thing they want us to do is they want us to find the inverse of the function. So the same rules apply. So since it's a function f of x, I'm just going to change it to y. So y equals 2 over x plus 3. Same thing that we did with the other inverses. We flip x and y. So now it's going to be x equals 2 over y plus 3. And you're still going to solve for y. So in order to solve for y, y is in the denominator. First thing I'm going to do is multiply y plus 3 to both sides. Cancels out, cancels out. From here, I have y plus 3 times it by x is equal to 2. I'm going to divide x to both sides. So now I have y plus 3 is equal to 2x. Subtracting 3 to both sides, y will now be equal to 2 over x minus 3. And then that is our inverse. Doesn't ask us to graph it, so we're just going to leave it at that. And that is being able to solve rational equations. Hope this helps. Until next time.